Okay, so now we are going by this command by dividing the left hand by dy and then right hand side by dx. We can now remove dy and dx from this equation. So we get this value. One more thing that we need to manually add the constant. Although there are a way to actually add the constant by using the integrate command, but I would not recommend that. We can just do it manually. Okay, that's much easier. So in the next set, I have entered the constant of integration on the right hand side. So I will execute that command. Okay, so now uh, I have to simplify this equation. So what I can do is I can divide both sides of this equation by -3. So it will be divided by -3 and also divided by -3, and now execute it. So here it is on the left hand side it's log and the right hand side it's log. And now for the removal of log, I know that I can remove this log by just taking the exponent. So what I can do is I don't have to put any calculation over here. I can just remove this from here. So exponent, by removing of the exponent, I can say that it will be 1 minus y power 3. But on this side, there will be the exponent. So for exponent, I will put the exponent function, exp function, bracket, and then bracket close. Okay, so now I will execute it. So it will be like this. It will be represented like this. And now what I can do is I can further simplify it. Okay, so for further simplification, what I do is I can subtract -1 from here and subtract 1 from here and there. So execute again. So it will be this. And now to remove this minus sign, I will multiply both sides by -1. So it will be multiplied by -1, and left hand side will be also multiplied by -1. So it is y power 1 by 3, and now I can simply take the cube of both sides to get it as the answer as. So let me see, if I take the cube of both sides, then this y power 1 by 3 is simplified or not. Because sometimes Mathematica gives some trouble in these kind of calculations. So for y power 1 by 3, I will use the control and then enter the 6 key, and then I will take power 3. And on the right hand side, I will also take the power 3. Same operation on the both sides. So control 6 here, and then 3, and then shift enter. Sorry, shift enter. Yeah, in this way, this y power 1 by 3 power 3 has been simplified into this. So this is the answer. So 1 minus e power 1 by 3 into minus c minus x power 3, which is the similar answer which we got from here. So it will be e power minus x. Well, the form of the answer is different little bit, but they will eventually be the same. Okay. Since over here it is minus c minus x, so we can take out this minus c, so it will be minus 1 by 3, so which is obvious from here. Okay, and then e power c can be taken out. Okay, so that was this question. So now let's look at some other question. Maybe example 2, I can say. Okay. So example 2. Let me type it here. I want to put a fraction. So for the fraction, I will put control and then forward slash. Control and then forward slash. Okay. That means control and forward slash. So there I will, this will be the fraction. So it will be 1 over t square. For square I will put control 6 and then plus again a fraction 1 over t, okay, then plus then minus again fraction y over t square plus y square dt. One thing you must be careful about when you write two variables, such as dt is a variable and this something in the bracket is a variable. If two variables, if you want to show them as multiplying with each other, so you can put a space between these two variables, or you can put a multiplication sign. So I normally use the space. If I don't put the space, then the Mathematica will take both dt and this thing in the parentheses as one variable. So that's why there is a, you should be careful about putting a space. That is only for the multiplication sign. For plus sign, there is no need to put a space. And now I'm adding another bracket. It is y exponent. So for the exponent, I normally use this exponent function. Okay, I don't use the e symbol in Mathematica. Somehow it caused some problem. So y times exponent y, okay, and then here maybe it's better to put a space between y and exponent because they are going to be multiplied, and plus again a fraction by putting control forward slash t over t square plus y square and then bracket close and then space dy equal to 0. And then again I forgot about for the equal sign, it should be a double equal sign for Mathematica. So this is the equation which I want to solve, and for this equation it seems to be it is the equation for checking the exactness. Okay, so we can do the exactness. So let me execute this first. So in this way the Mathematica has automatically formatted this equation, okay, into this format. So normally we use the dy and dx in this, but in this case the variables are in terms of t. So you can treat dt as like it is dx. So if I want to check the exactness of this equation, so I will take m and n function. So in this case I can use the assignment statement to define the function. So I will take m is equal to this function which is with dt. Okay, so I can just copy and paste. Yeah, it's a good thing is that we only have to enter the equation once, and then various parts of the equation you can copy and paste, so you don't have to type every time. Okay, so I take this m function. So this is which was same as like x function in dx dy case. So for the exactness, what you do is you take a derivative of m function with respect to the other function. So for example, in this case, I will need to take the derivative of this function. So for the derivative, there is a very simple letter capital D, which is used in Mathematica. Okay, and then you start it with the bracket, and then you enter the function. In this case, I don't have to enter the function. I just have to enter its symbol, which was m, which I have already chosen. And then I need to tell that whether I need to differentiate with respect to t or with respect to y. So in this case, I have to differentiate with respect to y for testing the expression. So close. So what I can do is I can also show it to be equal to derivation of y with respect m with respect to y. So I can put it like equal to my. So now I execute it. So I get this thing. Okay, so this expression. Okay, so now let's define the n function. Yeah, n is equal to which one? N will be the one which will be with the dy. Okay, okay, and control V. Okay, so this is the n, and I will execute it. Here I have got some error. It says that the n symbol is protected. Yeah, because n is a command, n is a function in the Mathematica. N is a function in Mathematica, so we cannot use it. So maybe I can use, I don't know, maybe double n, okay, and then execute it again. So now it has accepted it. Okay, so next I will differentiate n with respect to x. Okay, so I will put subscript x over here and then differentiate it. Differentiate what? nn with respect to x. Here it is not x, it is t. So okay, because we are using t in place of x, so here I should also put t over here. So I represent it as n. Now I execute this command, so I get this. So here it is minus 2t square and then 1 plus t square. Although it is not the same here in this case. Here you can see that partial m over partial y and partial n over partial t does not look equal to each other. But it may be because the expressions have not been simplified. So what I can do is I can use a command which is called as the simplify. Simplify. Okay. So it will give a answer like this. Yeah, simplify command around this derivative. So I will get minus t square plus y square over t square plus y square square. And here I will also use the simplify command. Simplify here. And now I can see that both are same. So now we can see that we can give the comment that it is an exact equation. Okay, or maybe I don't know. It is an exact equation, exact ordinary differential equation. Yeah, one thing you can do is that although I am showing these commands over here, you can write their explanation, short explanations as well, so that later on, if the reader wants to get an idea of what is going on this Mathematica window, then it is easy for him or her to judge what is going on. Okay, now coming back to this question. Now since we have found out that this is an exact equation, so as a next step we can find the solution. So we will continue this in the next video clip.